Now we're going to visit the material engineering department. Okay.
Okay, all right.
And we're going to visit one of the lab. So here is our professors, our beautiful professors. Professor Oratai, okay, she will introduce you to one of our laboratories.
Okay, nice to meet you.
Very
Okay.
nice to meet you. Before we start, let me introduce Ajahn Kasidit.
Okay, all right.
He is one of the
Okay, nice to
most
meet you.
famous young professor, right? He is a rising star in research in Kasetsart University.
Wow, okay, so great. Yeah, very honored to meet you here. And today we'll have a visit for our Faculty of Engineering and go to the laboratory. Okay, so shall we go?
Okay.
Okay, thank you.
Hi, let me introduce one of the research team in my lab. Actually, here we are the Department of Materials Engineering, and this is the 25th anniversary of our faculty right here. And we are dealing with a lot of materials. But for our lab, we kind of like do advanced materials. So let me start with the first theme that we are doing right here. It's about the hydroxyapatite. It's about the bone. Basically, like you can prepare the artificial bone. So basically, like in our lab, we can synthesize the powder of like the bone by ourselves, and then so we get the powder of the bone. We can just use 3D printer to get like the shape of the bone with the desirable property that we want. So this is one of the theme. So let's continue with the bone that you saw outside. So basically, like the way that we can do is make the hydroxyapatite, the powder, into the filament and use that 3D printer right there to get into the shape that we want. And we can also use some kind of other material to be the scaffold and then coat with the powder of the bone so that it can help in terms of osteoconductivity and to have the property similar to our real bone. We can use different kind of 3D printer to print to the shape that we want. So this is about the hydroxyapatite project, about the artificial bone project. The other project that we are concerning is about environment. So basically, what's happened here, we can make different kind of, you see this construction material. It look like traditional one, but when you hold it, you feel some different, right?
Yeah, this is lighter.
Exactly, thank. So we can tell the weight and density of the cement block. So how can it be very good to the environment? Because like normally people know that when we are making the cement, you need to just like explode the mountain, right? And that's like creates lots of dust, and you need to heat it at the temperature like 1600 degrees Celsius. But here we use like our very simple technique to make the cement and use the waste like the calcium from like the cockle shell or egg shell, and we use the temperature just only 900 degrees Celsius. So that reduce like the temperature quite a lot and save environment. And also, as you already know, that we can tailor the porosity and density. So that means there are lots of holes here, and we check with this. That hole can somehow trap the dust. So that we hope that this can reduce the problem related to PM 2.5 using our porous material. And don't worry about the durability because like it has the standard of Thailand industrial usage. We can also incorporate material to kill the germ as well. So this one can be porous and trap the dust and also can eliminate the germ. So that's the other thing about environment. What we can do is also we use another kind of 3D printer right here. We call it stereolithography. We put the material that can kill the germ and can decompose organic material inside, so that can do the wastewater treatment. So in this case, what we try is like we try to decompose the dye. Dye is considered organic waste in the water. So we just use our material to absorb the dye, and basically like we can treat it so the water resource gonna be cleaner and it is absorbed by here, and then we treat this one, it comes back to be the same. So basically this can be reusable.
Okay, we'll go to another part of our laboratory and let our Azan to have introduce this one.
Okay, my name is Kasit Panuswan. I will introduce briefly about my research. In the first theme, I'm trying to convert the biomass. It's a natural waste in Thailand. We try to convert into the carbon materials. It contains a lot of porosity and very high surface area. We can apply this for the energy storage application. And another work, we try to apply the plasma technology to synthesize the nanomaterials. For example, this one it contains a lot of nanoparticles inside this. It's a gold nanoparticles for application like biomedical application, or the sensors, and even for the energy applications. Yeah.
Okay, so as we know, actually just now we know, so he is the youngest professor, right, in our university. So for our Chinese students, if you have the same interest in this area, you will come to our Faculty of Engineering and consult our very handsome Azan to give you the guidance. Okay, thank you.
Yeah, thank you.
Yes, today we come to the KU Faculty of